Like I said, we're going to get started with something totally brand new. What we're going to be doing now is a little bit more modeling, right? So we're going to kind of jump back to more advanced modeling procedures. And so the way that I'm going to approach this is to actually to start off by maybe kind of showing you how you might think is the better approach to developing something like this and why perhaps it might actually cause a lot of problems in the future, right? So we as designers, particularly in modern academia, have this sculptural goal in mind, right? I don't want to, brand it as anything other than that, but we have this thing about us where we want to approach architecture like it's a sculpture. And so let me see if I can find a quick example of what I mean, but no, it's not. Well, you know what? I'm not going to worry about trying to pull something up last minute like this. But anyway, so what I'm getting at with that is that we kind of like have this tendency to want to extrude things along splines and create these really crazy, enclosures and envelopes. And it might look something like this, where essentially you have kind of a curve, and you guys don't have to do this with me right now, I just kind of want to show you what I mean. But you might have a curve that kind of goes back like this. And perhaps you develop some kind of a profile that you're going to map onto that curve, right? So let's say it's sort of like a singular, sort of tubular sort of structure. And then if it needs to be in a third dimension, then you might go through the process of modifying this to make it more interesting, I guess. And I'm just spitballing here, guys. It's nothing special. And let me just do a quick modifier so that it actually looks kind of believable. But yeah, we'll do that. All right, and then sweep, and I'll sweep this along that rail. Okay, so something like this, I mean, it's a pretty simple thing, but you see this kind of architecture in a lot of places, right? This kind of tubular, like this extrusionary or like folding, like hypercladding sort of environment. I don't know what to label it as. And eventually it'll do something like this where it's offset surface and, we'll offset it inward. And I'm going to go through all these steps with you in the future, guys. But, you see this very frequently in architecture these days. And don't mind the little screwy corner that I have here where it all melted. But what I'm getting at is that with this kind of a geometry, it's very, very hard to control for a lot of reasons. First and foremost, when you look at it here, at the end of the sweep, it actually, it pulls the geometry to be exactly perpendicular to the line at that particular moment. So it might not necessarily have the smooth or 90-degree or whatever it needs to be. It might not have the exact edge that you need, which requires extra steps in order to get it back to the orthogonal end, right? So I'd actually have to go through and do like a Boolean difference to cut the end of this off properly, right? So what we're going to do is kind of slow down this process and look at a more methodical way of generating geometry, because when you look at certain structures, it might seem like, and let me find an example. It's worth it for this one. It might seem like the geometry is super random, but it's really not. Here we go, something like that. Okay, so the way that these planes are kind of folding back on one another need to be very clearly thought through so that you can turn one face to another, right? So right now it's really hard to tell because it's super, the whites are really burned out in this image. But if this is off plane from that one, then you need to actually create some kind of a mitered corner or, a flat a flat clip on that corner in order to get your cladding to turn the edge. And particularly right here, there's some twisting going on that you need to figure out as the designer. So the reality is certain geometry gets sort of overlaid or created to control the finished product, and it gets even more particularly interesting, I think, when it becomes curved. Something like this. Right? So when it becomes curved, this one happens to be, generally speaking, pretty flat. I think it actually is flat. But you need to figure out if this is going to change planes like that other one does. Well, now you have a curve that you're dealing with at the same time. And it becomes incredibly difficult to do so in a lot of cases. Okay, so now you're dealing with like hyperbolic parabolas and stuff like that. Luckily, Rhino gives us a lot of great tools to pretty much automate that process. So what we're going to do today is develop sort of a tubular structure with a couple of very simple parameters, and then we're going to take that principle later on. I'm going to give you the assignment, I think, on Thursday. We're going to take those principles and actually develop an actual design from it. Okay? Are there any questions about that quick little intro? None. Okay. All right, so I'll stop in this video here, and then we'll go into the actual tutorial.